This
pretty
conference will
intensively.
now be recorded.
It's a 2 hours long demo that we had yesterday. Thanks for your patience. All right. So let's get started. So before I get started, I just want to, give an update on my style, okay, of teaching because it's a virtual class. Um, we you don't see me and I don't see you, and all you see is my computer screen, and so you need to know what my way of teaching is. I mean, at least the kind of tools I use, how I navigate, and all these things. Okay, so yeah, let's take 2 to 3 minutes to understand that part. Okay, so I basically use a Linux computer, not a Windows computer, uh, because Linux is the best. Okay, so the interface might be slightly different, but yeah, it's the same browsers and same features. Okay, so what tools I use? So I connect to GoToMeeting with my Google Chrome. Apart from that, I don't use Google Chrome for anything else. Sometimes maybe to open some websites, when we configure something, we might open Chrome. But otherwise, mostly I open all the presentations or any even AWS website through Firefox. Okay, so Firefox is the primary browser for us, for me at least. So that's what you're going to see most of the time. Okay, and any documentation, anything I open in Firefox. Okay, apart from that, if I have to, type anything, I use Atom, or a note. It's a notepad, simply a notepad, a type of editor. Okay, so you keep seeing this screen as well. And of course, when we talk about Linux operations or connecting to a virtual machine or anything, we use this tool called as Terminal. Okay, its name is actually Terminator, but yeah, it's one of the terminal emulators. Um, so this is another screen you're going to see regularly. Uh, Apart from these, not many other screens. Okay, only we will be toggling between these three screens. Firefox, Chrome, my Notepad, and the uh, terminal. Okay, terminal. So again, within Firefox, I mean, when it comes to some online tools, I keep using this apps.diagrams.net website to draw some diagrams because it's nice. It has some logos, and you can draw nice workflows and all these things. So I keep using this application, which is again in within Firefox only, on a browser only. Okay, so yeah, these are the four tools I generally uh, switch lot of windows, but I keep saying that okay, I'm switching to this window, and all these things. As you know, we have tabbed browsing everywhere, tabbed terminal, so I can open a new window within this terminal also. So this is one window and the other one is one window. So I keep toggling between different windows, but I'll tell you that I'm changing windows and all. Sometimes I might forget, but yeah, just pay attention to that. Yeah, so that's about it. So as I told you in the demo, I would not mind being interrupted, but not too often. Like, I mean, every 10 seconds, if you have a question, you better hold all the questions to the end. But if it's like some question immediately after I complete my sentence, please feel free to ask me immediately, if it is relevant to that topic. For example, today we are discussing, let's say, something related to networking, and all of a sudden if you ask me a career question, that doesn't make much sense, right? So I would rather you wait for the end and ask me at the end. That I will appreciate. Okay, if it's a question that is related to the current topic, yes, you can immediately stop me and ask. Or if it's something like um, you know your experience related, or how this topic is going to work in real time, or whatever it is, that also maybe you could hold it towards the end of the call, when I ask you for questions. Okay, so in that way the logical flow is not disturbed. But otherwise, I feel free to ask me any question, ask questions at that time. Okay, or maybe every day at the start of the day and also at the end of the day, you could ask me any questions. Okay, and it's very rarely, I mean, when I'm teaching, um, I might not open this window This is there in the background. I'm teaching on some other window. So if you type any message, I might not see them. So I would rather request you to kindly, you know, unmute yourself and ask the questions. Okay. And as I said, you have to participate actively. Don't log in through phones and uh, tabs. I mean, if it is not possible, I know sometimes you might be traveling or there might be some other issue with your laptop, or then it's okay. But generally, try to log in with a laptop. Sit in your work desk. Pay attention. All right, that will give you maximum benefit out of this course. Okay, so that's about. Yeah, this conference is recorded and it will be shared with you every day, post the class, like 1 to 2, 3 hours after the class. You'll get the recording link and you can follow it. Okay, and it will be there for you for a long time. Don't worry, it will not be deleted. Access will not be deleted. um, and we have classes from Monday to Friday, 6 a.m. to 7 a.m. IST. Convert that into your local times if you're outside India. Okay. And sometimes when I take breaks, very rarely, then maybe we'll have to organize, I mean, have classes on weekends also, but very rarely. I promise I don't want to ruin your weekends because I also don't want to work on weekends. All right. Um, so that's about it. Any questions before we proceed? Okay. And remember, there's nothing like silly question or stupid question. Any question is a question. Okay. We're all learning. We're all at different stages. Okay. Uh, so what might be silly question for someone else might be, something someone has never thought. Not only you. For example, um, Srinivas asks some questions. There is another Srinivas here. That Srinivas might not even know, okay, this might be even a possibility, right? So don't hesitate to ask questions. It's okay. Don't think it's, people might think something. Don't No one else knows you. Maybe one or two friends might know you, but otherwise it's okay. It's better to
Okay.
remove doubt.
So this training is more like a getting general idea, or I mean, I don't know how relevant this will be, more aligned to interviews and all, or this is more like a general training.
uh I'm not sure if you have attended the demo. If not, please, have you attended the interview, sorry, demo?
Yeah, I think I left a little early, but yeah, I attended the demo.
Yeah, so pretty much we are covering the tools, we're covering how to do it. So it's not a generic. I mean, it's a training definitely, but it covers in depth. It covers all the practicals. It covers, you know. I mean, I'm going to talk how it's going to be in real time and what your role is going to be as a DevOps engineer. What you're supposed to do. So yes, it will give you all the.
So
Uh,
you will cover all the scenarios, right? Scenario A, scenario B. What are the scenarios that you encounter so far in your career, or at least what you can expect in the job?
no, no. I see. We cannot cover all those scenarios, right? Because we are going to talk about a lot of technologies, and we're talking from basics, right? Ground zero. So imagine in these 49 50 hours, because we have 10 weeks or 11 weeks, at the most we are getting for our topics is 48 or 49 hours. Okay, in the 48 49 hours, you cannot expect me to take you through all the situations in all the applications, right? We are talking concepts, we are talking how it is implemented in the real world, but the troubleshooting part is something everyone has to figure out on their individual time. I mean, at their individual turn, whenever that situation happens. No one can teach you troubleshooting, or no one can teach you, bug fixing, right? It has to be happening on the job. So you will learn the concepts, you will learn the syntax. Okay, maybe I'll also encounter some issues while doing the demo on the call. There I'll show you how to fix it. But tomorrow, if you face the issues, because there might be some upgrade to the some application and there might be some need you need to do, so you have to reference the documentation, you have to Google and fix those errors. So I would not say I'm covering all the scenarios, but as I said, I would show you how it happens in real time. Okay, how you are going to do it in real time. I'm going to show you the application, but again, troubleshooting and debugging that happens on the real time job only. There only you will go and fix those issues. So I cannot talk about all those scenarios, and practically it won't be possible within this 10 weeks course.
Okay.
Yeah. My point is to, kind of get all the basics right. You understand every concept to equip you with that knowledge, so that even if there is some issue, you should be able to troubleshoot on your own. Okay. Just like the old saying, give a fish to a man for a day, it will feed him, and teach him how to fish, he will be self-sufficient throughout his life, right? So it's it's something like that. Okay, I will equip you with all the basics, all the knowledge, all the tools and their applicability, where you apply them and how to apply them. But then when you encounter some issues, you will be in a position to troubleshoot yourself. All right, any other questions? So it's a first day, so yeah, you could, I will go easy on the topics. You could ask me any questions and we can proceed. Okay, and again, in in yesterday's demo, okay, we have seen number of topics, but that doesn't mean we are going to cover all of them in the same order. Okay, for example, some of these things maybe initially we'll cover the IT architecture part, networking, and all these things. Then we'll talk about account AWS account creation and all these things. Then we might not exactly go in this flow. We might start something with EC2 so that you understand how to create a Linux instance. Then we'll talk about Linux. Then maybe some scripting. Then we'll come back to AWS. So it's not like straightforward. It's in a logical order, which will better help you grasp all the subjects. Rather than covering this, I might break Linux into two to three different sections. First I might only teach basics, then we might go to some other AWS topic which is more logical, then we might come back to Linux to learn some advanced topics. Okay. All right. Any other questions?
Kiran,
Ye-
yeah, Uma here. Can we target to explain wherever applicable with a proper example so that it's easy for taking and understanding it? I would suggest rather.
so what do you mean by example?
So you mean a real-time example or a scenario-based?
Okay. So yes, as I said, we are going to do how it's like in real time, right? First, we have to learn individual piece, then we have to piece it together. And as I told, again, I've clearly said in the demo, we are going to go in an incremental order. First, when we are going to learn, we might learn only small pieces. But when we go towards Terraform, we'll use all this knowledge, accumulated knowledge, and we'll try to create Terraform for a complex infrastructure. When I say complex infrastructure, maybe two virtual networks, okay, or multiple virtual machines. That's all up to you to create. I will show you how to do it. Okay, I'll give you a task, that how it looks like in real world, what kind of tickets you might get in real world. What happens, they will assign a ticket. Hey, I need a virtual network and three VMs. Okay, so I already might have told you how to do a single VNet, how to create a virtual machine, everything through Terraform. Now you have to group all this together and create your own Terraform code after the class, and next day come to me and say that okay, whether you have created it or not. Okay, similarly, I'll teach you Git and GitHub, and I expect you to push your scripts to GitHub and show it to me, and try to create pull requests and other things by yourself and explain them to me. All right, explain them to me in the sense, ask me any questions if you have. So yes, it's going to be how it is in the real world, but not exactly the real world infra or other things. and again, like I told you, right, it's cloud, so it's the same everywhere. The way you create virtual network here today is not different from how you do it in your organization. But in your organization, there might be some changes because you might be connecting to uh, your organization or the future organization. They might already have some servers on premise, some servers on the cloud. Okay, so the way you create VPC on AWS doesn't change whether on your own AWS account or on your um, customer's AWS account. Both are same. Okay, there's not much difference. Maybe some networking concepts might be unique to your organization. The way they organize their total hub might be different, but most of the all the AWS concepts are same wherever you apply. So that's the beauty of cloud, right? So what you learn today will not change when you apply it in your organizations. Okay, so we're going to cover all those situations, basic, when I say basic, the fundamental blocks of how you create your cloud infrastructure, and we group them together. Yes, we go with examples only. It's not just generally explaining concepts and leaving it there. It's going to be more of practical, hands-on, rather than PowerPoint or PDFs. We will talk a lot of, we'll do a lot of hands-on in our classes.
Hi Kiran, good morning.
Yeah.
This is
Good
Arun.
morning. Hmm.
I think testing is also part of our Devops method, right? So,
Testing?
what is our testing is also part of Devops method, right?
No. Testing is not part of DevOps. Okay. So testing, your voice is breaking if you're speaking.
Okay.
No, so testing is not definitely part of uh, DevOps. You need to integrate the test tools with your DevOps pipelines, like CI/CD pipelines. That doesn't mean you need to learn the testing tools from scratch. Okay, if you learn testing tools, that would be awesome. Okay, if you also have the development knowledge, that would be awesome. But that's not no one would ask you about uh, testing tools knowledge. But what they might ask you is if you have integrated testing with your CI/CD and how you did that. For example, which plugin you use to connect to run your test cases. If you're saying you used a Java application, you could say you integrated something like JUnit, but you don't have to learn testing itself. Yes. Any other questions? All right, then let's get started. So we'll talk about a very simple topic today. Um, so here's a question for all of you. You asked me a lot of questions, so here's a question for you. If I type google.com and hit enter, and from the time I hit enter to the time page loads, what happens?
Well, it looks on the internet that that browse that address, web address, and try to
Hmm.
locate that web address and load that page. It's just more like a
Okay,
call.
more
I
like a
think it
call. Okay,
communicates with the server.
okay. So let's
It
say,
hits your local server, wherever, whichever country you are in. If you're in Google India,
okay,
if you're in India, Google India server will be hit.
okay, okay, right. So this is your laptop. So this is your browser. You just typed in google.com and it goes to server, right? Someone said server or local server. Okay, let's say the server is this one. or maybe more relevantly this one. Okay, so this is what's going to happen, right? I'm going to directly go to the server. That's it. That server will give me the web page. Is that all? Is that what's going to happen when I hit any URL? Is there anything else?
I think it connects using network with the server.
Okay, okay, okay. So we've talked about few things, right? What is a network? What is server? First, we'll come to what is a server. What's a server?
Where the data is stored.
Where the data is stored. Okay, but what it is? So server stores data. Okay, but what is a server actually?
It's OS like operating
Group
system.
of multiple.
It's a OS.
Mm.
Okay.
Group of multiple.
Sorry, someone is saying something, but not audible. Little louder, please. Group of something was said. Network. What is network?
Group of multiple machines.
Okay. So multiple machines connected together is a
Connected.
server. Okay. All right. So a server is, someone said, like where a data is stored. Someone said it's an operating system. No, it's not an operating system. It runs an operating system. Okay. So simply put, a server is nothing but a computer. All right. Your laptop could also be a server. My laptop could also be a server. Your desktop could be a server. Server is a system which serves something, meaning which gives some data. All right. But when we talk about this server means, but when you're running applications in production environment, these computers need to run 24 hours, 365 days, right? So our laptops might not be equipped to do that. Okay, most of the modern laptops can handle, um, you know, a huge workloads, and we have laptops with 32 GB RAM and 8 cores and 16 cores. It's not 16 cores, I guess, yet, but at least octa core is very common these days in laptops, and 32 GB is also like not a big deal these days, right? So you have laptops like that, and they can also pretty much handle heat and all, but definitely they cannot work 24/7, 365 days. They'll shut down at any given time for whatever reasons. Uh, Not that physical servers don't shut down, they too also shut down. But when you talk about a server, it is nothing but a computer, okay, which has a RAM, which has CPU, which has some internal hard disk, which has the networking card through which you can connect your LAN cables, and a VGA or a HDMI or VGA cable through which you can connect a monitor. So a server in essence is a computer, right? But when we're talking about servers in the application, I mean, in a data center, these are specially made machines that can, run for a longer time. They have better processing power. They use better RAM slots. They use better motherboards than our regular consumer electronics. Okay, so in terms of functionality, a server is nothing but a computer. Okay, I could install multiple virtual machines on it. Each of them has its own operating system. Okay, so sometimes we call a virtual machine as a server as well, or we simply call it as an instance. Okay, a virtual machine is nothing but, as I said, a single machine can be divided into multiple virtual machines. Each of them can run multiple operating systems. Yes, we'll come to virtualization in a bit. Maybe tomorrow we'll discuss what virtualization is. But right now, just understand server is a physical machine which is generally a computer, and it depends upon what you run on it. You can run web applications on top of it. You can run mail server, which will be able to receive and send emails. You'll be able to run a database or an application software which is generally referred as middleware, or you can run some caching servers. There are a lot of use cases. Okay, so it's not only stores data; it serves a specific purpose. Like a web server can serve you web pages. A mail server can serve you receive and update mails. The data might be stored somewhere else in the database server, but you know the mail server will do that. And it's not like you have some servers which are web servers. It's not like you have some servers which are application servers. A server can be made into whatever you want to. Today, a server can run only web application. Tomorrow, you can uninstall the web application and install DB software, or you can run both the things at the same time. Okay, so it's just a role you want the server to assume. The server can assume a web application or a website web server role, or it can assume a DB server role. It's not like you have separate servers for each of these functions. Okay. All right, we'll come to that back. And networking, as someone said, is a group of interconnected devices. Very right, bang on. Okay. So our home is also a network. You have a router, you have multiple devices connected to it. And if you can configure your home networking, in fact, you can communicate with one device to another device without going through internet, only through router. Okay. For example, today, how you are casting your videos on from phone to TV, right? It acts through your router only, right? So yes, our home network is also a network which is connected to different networks. So we are all from different home networks, right? Each of us are from different networks. We're all connected through internet. Internet is the biggest internetwork, which is network of all networks. Okay, all right. We'll come to that networking part also. But how does my browser know to which web server or which server it has to go to based on the URL?
IP address, which IP address will translate to the country, and probably from there it will translate to the server address in that country or geographical location.
Okay, so IP address is, so what is IP address?
So just like we have home addresses, right? Every terminal, every instance have its own IP address, so that it's unique and identifiable.
Okay, so IP address is unique and identifiable over the internet. Okay, right. So, but I did not give the IP address, right? I just gave the google.com domain name or the URL, as you can call it. So how does my computer know the IP address?
This name will be resolved to the IP address. Google.com will be resolved to the IP address.
Okay, who resolves that, or where does it get resolved?
ISP, Internet Service Provider.
Internet service provider. Okay, what is an internet service provider? Someone who gives you internet. For example, in India, it could be Act Cable or Airtel Broadband or BSNL Fiber to Home. What else? You have Vodafone, Geo. Everyone is offering ISP, right? So one of those service providers. In US, it could be Verizon or AT&T. What else do you have?
Spectrum.
Sorry, what was that?
Spectrum.
Spectrum. Yeah.
Spectrum.
So all of these are your ISPs, internet service providers. Okay, just let's. This is more likely to represent what do you call? So someone has said it is going to be resolved by your ISP, internet service provider. Yes, ISP has something called as DNS resolver, which mostly resolves the IP addresses. But let's say it's a completely damn new website you created, or your friend has created and asked you to access. No one has ever accessed it. So will your ISP have that information?
No.
Then what does your ISP do?
It hits the Google server probably to search that.
But how does it know it has to go through Google? We don't know the IP address, right? So remember, guys, folks, IP addresses are for human beings. Computers only understand IP addresses. So the first part is for my browser to get the IP address. right? So we are on the right path. We need to find a IP address for the domain name we enter. Okay, so what is DNS? Domain name service. So it's like your telephone directory which has a key value pairs, meaning it has a domain name followed by what IP should it go to. Okay, the next
So I
part
think
is
domain
mhm,
name will be tied to IP, probably by your wherever you purchase that domain name, right? I think there is a site where you purchase
right,
a domain name.
correct. That's a good point. Okay, so you have something called, so if I want to Google, if I want to create a google.com website, can I create?
No, it's already taken, so you have to try something new.
So
It's
where do I
unique.
get that information?
So I think I don't remember. I think there is a service provider where you buy domain space. You enter your name, and it will say, okay, this is available. This is not available.
Okay, but if I buy from different if I buy from a different service provider than what Google has bought from, will I still be able to create google.com?
No, no, no. It's already been taken. Unless
Okay,
you add that dot co dot or whatever. I mean, if you change the
no,
country
no,
name,
even
maybe.
okay, right. So registrar, yeah, right. So now we have covered another puzzle in our flow, right? Uh, so if you have to create your own website, folks, okay, it could be anything, your name.xyz, your name.com, or whatever it is. You have to go to someone known as a registrar. Okay, a registrar is someone from where you can buy domains. Okay, so what are some of the examples from where you can buy your domains? You might have heard about GoDaddy. They do a lot of marketing but bad service. Okay, so registrar is someone from where you can buy domain names. Domain names are your website names. They are not websites itself. You're just buying a name for your domain, for your website. Okay, so for example, google.com is one domain, wikipedia.org is one domain, you talk of, like, aws.amazon.com is one domain, which is a subdomain of amazon.com. Then you, you think of anything, okay, any website, google.com, apple.com, okay, or mm, .gov.in, any like nic.ac.gov.in. These are all domain names only. Okay, so even before you create a website, you need to have a domain name. Of course, you can parallelly do that. That's not a problem. So a registrar is someone from where you can buy domain names. So you have examples like GoDaddy, you have Namecheap, um, you can buy it from AWS DNS itself. Okay, there's a service called as Route 53, which we are going to discuss in our course. So from AWS Route 53, you can buy a domain name. What else? I think there is something called as Big Rock or something. Come on. So all these are these are some of the registrars from where you can buy your domain names. Okay. For example, if you want to launch your application called as, let's say I want to launch my own website as kiranops.com. So I should go to one of these people and see if that website is available. Okay, if it is available, I have to pay some monthly yearly price and take that domain name. It's not my website again, just the name for my website. Okay, so how do these people know that, for example, there is another Kiran and he goes on by kiranops.com, and I don't like GoDaddy with my bad experience, so I'll go to Namecheap and try for kiranops.com. How does it know that kiranops.com is already taken? Yes, as you might have rightly guessed, there is a central database and it is maintained by two organizations known as IANA and ICANN. Okay, I mean, I think ICANN is responsible for the domain name. It is known as Internet Corporation for Assigned names and numbers, if I recollect correctly. And IANA is what is that? Internet Authority for I forgot. IANA, Internet Assigned Numbers Authority. Sorry, Assigned Numbers Authority. So this deals with IP addresses. Okay. Whereas ICANN, which is Internet Corporation for Assigned Names and Numbers, this deals with all the domain names. Okay. So these are all non-profit organizations. Okay. Um, so they decide what level of what kind of top level domains are nothing but the .com, right, .org, .in, .co.in, .edu. What else do we have these days? We have everything, .tech, .xyz, .me, .website, you name it, you have them. Okay,
.gov,
all these .gov, yeah, .gov has been
gov,
there from some time. Yeah, you have .gov.in also, .com.au for Australia, for example, .com, .co.uk for UK, and .il for Israel. You name it, you have all these domains. Okay, so what is ICANN? ICANN is the um, organization which makes decision on these things, like what top level domain should be allowed, and all these things. And also it creates the central database of all the domains. Okay, for all the websites, all the domain names. So even if I buy from GoDaddy, because when I search in Namecheap, Namecheap searches in ICANN database, not in its own database, and see if kiranops.com is taken away by someone. If it's already taken by someone, it says it is not available. Okay. So you have your registrar. Of course, your registrar should know where your application is hosted. So you might upload your IP address in your registrar information. Okay. Within your registrar, you might see something like, google.com. You can update an address record like this. Again, we're going to talk about DNS in depth. I mean, we have a practical session of DNS. I'll show you how to create a website, or rather how to create a domain name, and how do you link your domain name with your server. All these things we will talk about it. Okay, so maybe you can update your domain name in your the IP name in your registrar, and your registrar has your information. But your browser will not directly come to your registrar, right? First, it's going to check if someone has already visited, it will be stored in the computer. I mean, if I have already visited, it might be already stored in the computer for the next 24 hours. So it will immediately pick up the IP from there, and then directly it goes. Okay, some routers have capability. I'm talking about your home routers. Okay, some routers have the capability to cache DNS entries. For example, someone else might have accessed my brother might have accessed the same website before I did, so it's already cached in the router. So the router will provide me the answer even before going to the ISP. Okay, but let's say it's not also there in the router, then my router will forward it to ISP's DNS resolver. The DNS resolver will have all the queries cached in it, so it should be able to give for the most of the common websites. Let's say it is not even there because it's a completely new one. Then where does my DNS resolver from the ISP go? It will not directly go to a registrar. It will go to something known as root server. Okay, so there is something called as a root server. This is root of your DNS. Okay, so you might wonder what it might be, but I'll come to that in a minute. Okay, so first thing, it goes to your root server. Your root server has information about all the top level domains. So when you type a website name, for example, wikipedia.org, you don't there is a dot at the end. We don't have to put it, but it is implicitly understood that there is a dot. Okay, and that dot itself is known as your root server. Okay, so that the root server will then forward your request to what is known as a top level domain, TLD. TLD, top level domain. Top level domains, again, like I told you, could be any of these things. .com, .org, .in, all these are top level domains. So the top level domain will then the top level domain will tell, okay, I don't have the, so the root server might have or might not have the IP address based on whoever it is cached, because the root server is not only cached by my ISP, not only queried by my ISP, but people from other ISPs also will go to root server. So sometimes you might get the answer here itself. Okay, I know where this is. I already cached it in my database. Take the IP address and it will give to ISP, and ISP will cache it in its own database for the future requests, and it sends back to your router. If your router has the capability to cache it, it will cache it, other and send it to my computer. My computer will also cache it. Okay, so next time if someone from my home is accessing the same website, it need not go up to ISP also. From my router only it will give it, but it is only cached for 24 hours. But later you have to again do a requery, get the new information. Okay, so yeah, let's suppose no one has ever accessed that website, so it will go to the top level domain. So let's say there are multiple top level domains, right? If you're talking about google.com, it will go to .com servers. .com top level domain servers. Okay, this server says, I know this is a .com server, but I don't know the IP address, but I know where it is bought from, because when you register a website, it will also know where you have bought it from, right? So this server has the information about where this particular service was, where this domain name was bought from. For example, if I bought this website from Namecheap, okay, as I said, Namecheap is a DNS, sorry, Namecheap is a domain name registrar. It will forward my request to registrar, and the registrar says, oh yes, he has bought it from me, and this is the IP address, take it. And on the way back, it is cached at every single point. Okay, and there is something called as time to live. It will generally cache up to 24 hours or 86,600 seconds or something. Till that time it is cached in your all the places, so you don't have to look for every time you want to go to that website. Okay, so it's constantly being looked by someone or the other, so it is cached at various locations, so you don't have to do all this path all the time. But this is what happens when your website is being resolved for the first time, and this IP address will be for the server. Okay, we'll not talk about the country specific IP addresses now, that's advanced routing. But let's suppose it goes to a web server. Okay, so this is the actual flow. Okay, you first your browser will check its own cache. It will check your computer's cache. If not, it will check in the router, then the ISP DNS resolver. If it's not available, DNS resolver will forward the query to root servers. These are all DNS servers. Okay, so the root server will forward to the top level domain. The top level domain will forward it to the registrar, and the registrar might or might not have information. Sometimes what happens is I might have a lot of websites or applications I want to maintain, so I want to maintain my own list of domain names instead at the registrar. Okay, so what I do is I maintain the DNS in my own servers or another server which is in my premise, but my registrar still should know that I'm maintaining my DNS somewhere else. So there is a concept called as name servers. So you have to update the name server information here. So the name server might have another IP address or a domain name, like DNS dot I said or whatever it is. Okay, these are like global IP addresses. So it has the name server information, meaning the registrar tells you that, okay, I know he has bought the website from me, but he's not maintaining the domain in the IP information with me. It is there in some other location. Go to that location. Okay, so here you can maintain your own DNS. Again, we'll see all this in practical application when we create a website domain name and do the DNS update using Route 53. So that is there, but for right now, understand that there is a concept called as name server, which will forward to the actual place where your DNS is being hosted. Okay, so yeah, this is all good. This is how DNS generally works. Now coming to this one, let's say we all thought that there is one single server. So if it's a single server, can it handle all the load for multiple users from multiple places? Let's suppose, let's forget about the regional places. Even if it's assuming it's only India specific or not, we'll come to that part. But let's say there is only one server. Will it be able to handle all the loads? All the load, not loads.
It depends on the resources available in that server.
Okay, let's say it has 1 terabyte, 2 terabyte of RAM and 464 cores of CPU. Will it be able to handle?
Once it max
Maybe,
out, then it try to look it up
maybe,
for some other. Yeah.
maybe it can handle. Um, but again, remember, in the world of IT, right? Your machines are, it's a given. Meaning, you can always assume that systems can go down at any given point in time. It could be a software failure, it could be a hardware failure, networking failure, whatever it is. Okay, so when you have only one machine to serve your website, it could be as great as big as a google.com website, or a simple um, you know simple internal application for your company, or something like you created a startup and you want to have a product page for your own product. Doesn't matter, whatever it is, just having one server is known as single point of failure, meaning it is highly probable to be shutting down, not shut down. It could be because of some software issues, it could be some networking issues, or whatever it is. But if you have a single server for your application, even if it's a small application, doesn't matter. It's a not a recommended practice. You need to have at least two servers to serve those requests. Come on, why is it not copying it? Okay, is you have to have two servers to serve it all the time. But DNS is a simple, I mean, the way you update addresses in DNS is very simplest format, like, domain name, IP address. Okay. But how can you, and as someone has already said, IP address is something which will identify a server on the network. Okay. So if I can only update one IP address in my domain name, what's the point of having two servers? At any given point in time, the traffic will go to only one server. Yes, I can, kind of redirect the traffic once it fails. Um, I can redirect the traffic once it fails from the primary to secondary, but the 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 purpose is still not serving, because you might still encounter outages, uh, and users might see page cannot be found or something like, or HT, service not available errors when you're trying to
So
do the failover.
load
Sorry.
balancer maybe in the middle. In the middle, maybe you will have
Yes.
a load balancer.
Yes. So you need another layer, okay, which will actually make sure that it will send the traffic between these two servers. Okay, it could be another physical server, another server. Okay, we'll not talk about physical and virtual servers yet. Okay, it could be another server. Okay, whose job is simply, sorry, okay, whose job is simply to take requests from the end users and redirect to one of these servers.
So how do we know in order to redirect, right? We need to know the capacity load of one server that it can handle. How does those data gets driven or captured?
Why do we need to know that?
So
You
okay, from a server one, right? If somebody is trying to hit, and I think when it looks at, okay, redirecting, should I direct it to this server or that server? It needs to know
hmm,
how many user load on that server, and how does it? I mean, how does it calculate all that?
okay,
Where do we have?
yeah. Yeah, we'll talk about that later. The reason being later is because load balancers have a lot of functionalities. One of the functionalities is, to be able to read the configuration of your VMs or the servers. Okay, so yes, that is there. There are a lot of options where you can set your redirections or load balancing. It is called as load balancing algorithm. You could do a round robin, meaning first request goes here, second request goes here, third request goes here, fourth goes here, so on and so forth. Or you could set weighted requesting, weighted, whereas it might be a bigger computer in the sense higher specs, more CPU, more RAM. This might be a smaller computer, lesser RAM and lesser CPU. Then you can say 80% of the request should go here and 20% should go here. So you can configure all this in your load balancer. Again, load balancer is also nothing but just a software running which will redirect your request to either of these servers. Okay, based on the algorithm you set up. You can set up various algorithms to do the redirection part. Okay, but let's say it's a simple round robin. One request goes to the first, second request go to the second one. Okay, so that should be fine unless you have a application where users might have to connect to the same server for a longer time, banking applications and all. But yeah, we'll come to that later. So this IP address will be updated in your DNS name. Okay, and the request will come to this load balancer. The load balancer's work is only very simple. Just like a receptionist at a office, it will redirect to either of these things. Like, if you go to a bank, you go to the how may I help you desk, and they will say that, okay, go to counter 4 or counter 5. Okay, that is also automated. You punch in your mobile number, you'll get a OTP. You enter the OTP, and it's going to tell you what is your number and which counter you should go to, right? So yeah, load balancer is also something like that. But it will not be keeping you in waiting. It will immediately transfer to one of these machines. Okay, so these are looking ugly. So let's come to, let's talk about virtual machines only. What is virtual machine and all, we'll think about later. Let's just think that it's a computer which is running its own software. So let's put small boxes here instead of bigger ones. And of course, this load balancer can be run on any of the servers, any of the virtual machines, using some software like HA proxy or Nginx. All these can be used for your load balancing, or in most of the cases, what you do is you use a networking device which is known as load balancer itself, which is specifically created to load balancing only. Okay, so you might use a load balancer instead of a virtual machine here. Okay, so these two machines are generally identical. They run the same set of software. They have the same set of configuration files. They have the same operating system and all these things. So even when you're doing any updates to the operating system or the web application software, you update on both the machines. Okay, I mean, I'm just talking about two machines. There could be 4, 5, 6, 10, and any number of machines. Your load balancer will be able to send the traffic accordingly. Okay, so but when you're running an application, you need to it might store a lot of data. Okay, you might have some forms where users need to fill in. There might be a survey, there might be some other information you're seeking for users, and it has to be stored in database. So you need to have database. What is database? Database, as you know, is something where you have rows and tables. But from the computing perspective, it is also another software that you need to install and run. For example, Microsoft SQL Server or MySQL database. All these are softwares that you need to run on your virtual machines. Of course, you can run the database server also here and here. So you can run you can run both the web server and also the uh, database server on the same same computers or same servers, but it is not recommended because there might be a resource crunch. Database might take up all the resources, then your web server will not function properly. Okay, or vice versa. Generally, database servers take up all the RAM, though they don't use it, they keep it in their disposal. That means your web server will not get any RAM. So it is good to, you know,
Have a separate server with database itself.
exactly. You need to have a separate server for your databases. Now let's take another kind of machines. Okay, simply call it as separation of duties. Okay, so you might have a single database. Again, you can use a single database. Again, as I said, having anything as a single one is a point of failure. So you need to have at least 2 to 3 database servers. Okay. In this case also, how do computers connect to other computers? Computers also connect to other computers using IP address only. So if they have two machines, how do they connect? Again, there should be a internal load balancer between these applications. So in the configuration in the web applications, you will upload that if you need to reach out the database, reach out to this IP address, and that IP address will be of a application load, a load balancer, and this load balancer will redirect to one of these machines. Okay. So this kind of setup is known as a three-tier architecture. You have application layer, you have you have web layer, you have database layer, and you have the user. Okay, this is called as your three-tier applications. But sometimes you need a middleware processing. For example, web server is only to render web pages. Okay, whereas database is to store data. But there might be some business processing. Take for example google.com. Google.com, when you type in your some search query, does it give uniform results to everyone? No, right? It will check my previous history, it will check my recent history, and based on that it will give me output. So that means there is some computation that is happening, some computing, some calculations it is doing. So that is done. Not your web servers are typically only able to deliver you web pages. The computation should be done on some advanced application like a Java application or a Python application. So you might also have your app layer, and finally you might have your DB layer. I'm just putting different kind of pictures. Okay. So you might have a database layer. So this is, I mean, some people call it as three tier as this one. Okay, where you have web app, web layer, application or business logic layer, and a database layer. This kind of setup is known as three-tier application. Okay, three-tier architecture. But sometimes you not only have three, you have more than three layers. You have caching, you have analytics, a lot of other things. That is called as N tier, which we will talk about tomorrow. Okay, so this is your web layer, or web tier rather. This is your app tier. Finally, the database tier. Okay, so this is how your applications in real world look like. I mean, a simple application. Google will have much more components, not just web app and DB, and not they don't just run two servers; they run multiple servers. Okay, and maybe they are running in terms of containers, which we will talk later, of course. Okay, so this is a simple three-tier architecture, but as I said, we have complex architectures which are known as N tier. N means it could be any number more than three. Okay. So tomorrow we're going to talk about N-tier architecture, and we are going to talk about firewalls and security, and how do we manage connections to our machines and all these things. Okay. All right.
So Kiran, just a request, right? I think maybe we can start class on 7:35, 7:40. This way we get full hour. But at the end, we can
Ah,
keep the question answer sessions. This way, who needs to stay on
seven.
can just stay on. And hello.
Okay. No, no. I have another class starting at 7 o'clock. So we will have our only 6 to 7 as our main time.
No, no. I think 7:30. When I said it, I said U.S. timing, CST.
Yeah,
It's
yeah.
probably
You mean
translation.
CST, right?
Yeah, yeah, yeah. So
Yeah,
I think
that's my
whatever
6
we
a.m.
plan for, right? Yeah, plan
Mm.
for. Let's start on maybe 5-10 minutes here and there. But I think if we keep on asking questions in the beginning itself, then
No, no,
that'll
I
be
won't do that. I won't do that. Today is the first day, right? That's why I've asked you.
okay. Okay, okay,
Yeah,
that's good.
yeah. So it's not like I'll wait till 20 minutes to start my topic. Today is the first day, so I gave introduction about how I teach and all these things. Otherwise, we start at 6:05 at
Yeah, no,
max.
even our candidates, right? Everybody's asking questions before even we start. I think
No, no,
since
that's
everybody's new
totally
to this.
understood. Yeah, because
Yeah.
it's first day and definitely everyone has their questions. Yeah, we'll definitely start at 7:30 your time, CST.
Okay.
7:35. Take it, take it at 7:35.
Yeah, yeah, yeah. 7:35,
All right.
7:40 should be good. But
Yeah,
yeah.
yeah, yeah, definitely. Only today we have that slow introduction session. All right, folks. If you do not have any questions, we'll call it off and talk to you all tomorrow. Thanks for joining. And definitely, this is going to be an interesting session. Do join every day and participate actively, ask questions, answers. And I'm glad a lot of people spoke up today. Not every batch actively participates, and that's not really good for me as well. It creates a sense of frustration whether they're following or not. All right. Talk to you all tomorrow. Have a good evening or good day wherever you are.
Okay. Thank you. Thanks.
Thanks, everyone.
Thank you.